Hello. Can you hear me?
Yes, sir.
Yes. Yes.
I'm starting.
Please.
Good evening, ladies and gentlemen. My name is Dr. Prabir Neogi, and I am now starting the second webinar of our Sustainable India Conference. I hope many of you attended the first webinar, which was held yesterday, and therefore you will have some idea of the quality of the presentations that were made. They were both most informative and also very relevant to the subject. Today we shall focus on a slightly different theme. The theme is seeking answers for a sustainable future life, empowering young activists in India for the way forward. So yesterday was a more global and umbrella type approach, and today we are focusing on the work of the young activists, including, of course, the young professors and research workers who will be speaking. Without further ado, I shall ask Dr. Arup Bhattacharya to say a few words after we have played the Invocation by Rabindranath Tagore, with which we started the conference yesterday. This invocation is recited by Dr. Arup Sengupta of Lehigh University, who is also an alumnus of our alma mater, our Old Bengal Engineering College. Over to you, Shreyan.
Yeah, thanks, Prabir. So just before playing the presentation, Prabir, do you want to call up about the feedback form for yesterday?
Okay, yes. All right, I'll do it right now. All of you, with your email, which provided the access link to this seminar, also received a link to a feedback Google form. And I urge all of you to access that Google form at the end of this webinar, and at your earliest convenience, fill it out and send it back to us. This is our way of getting feedback about the two webinars and the conference in general. Thank you for reminding me of that.
Rabindranath Tagore, more than being a Bengali, Indian, or a Hindu, was a true citizen of the world. Two of his poem songs are now national anthems of independent India and Bangladesh. The most celebrated poem from his 1913 Nobel Prize-winning Gitanjali, or Song Offerings, where the mind is without fear, still resonates with all sections of the people around the world. Some Nobel Prize winners in the last few decades have read this poem as part of their acceptance speeches. Hollywood celebrities recited it for launching humanitarian movement. Silicon Valley entrepreneurs upheld the poem to glorify the transformative power of technology benefiting humanity. And judges in other countries took oath by reading this poem. Here are the inspiring words from the poem. Where the mind is without fear and the head is held high, where knowledge is free, where the world has not been broken up into fragments by narrow domestic walls, where words come out from the depth of truth, where tireless striving stretches its arms toward perfection, where the clear stream of reason has not lost its way into the dreary desert sand of dead habit, where the mind is led forward by thee into ever-widening thought and action, into that haven of freedom, my Father, let my country awake.
I can only say that in the last 100 years, very, very few people have been able to improve on that. I now call upon Dr. Arup Bhattacharya, the founder of the 5i Foundation and of ADI Associates, one of the two groups that have jointly organized this seminar, and I should add, a distinguished alumnus of Bengal Engineering College, to say a few words. Over to you, Arupta.
Thank you, Prabir. To our dear sisters and brothers of India and all around the globe of all ages and persuasions, greetings. From the bottom of my heart, I am delighted to welcome you for this second day of webinar of the most relevant challenge facing humanity: how to live a sustainable life, yet fulfilling our dreams of life with relevance to Mother Nature, the source of all lives. My hats off to dear Anjana Ganguly Roy, President of GAABESU, and her outstanding leadership teams, along with dear Mr. Prabir, you, and also our inspiration, Dr. Arun, our dear Arunda, for organizing such an impressive array of speakers for yesterday and today. And also the anchors and the speakers of today who has made this program into a reality. Today we are looking forward to learn from our young pioneers. Our generation are being confronted with unprecedented challenges due to multifaceted and complex issues, questioning the sustainability of life itself. In our own lifetime of 8.2 decade, a trivial lifetime when compared to the human existence of 20,000 decades. Population has surged 3 times to 6 billion. Forestation has shockingly reduced from 60% to 30%, reducing the oxygen for our life. Glaciers across the poles and Himalayas are disappearing at an alarming rate, raising sea levels. Cyclones and forest fires becoming too frequent to manage. And it's shocking to confront the reality that much due to our dependency for energy need from fossil fuels, emitting 51 billion tons of CO2 and hundreds of million tons of methane every year, destroying our very fragile ecosystem, which is only 50 miles deep and sustains and nurtures life for millennia in this beautiful planet. And we are the latest evolving form of that life, the human one, by the grace of Mother Nature. In this reality, in this daunting challenge that we face. We have no option, but must rise to the challenges and transform the perils of today's global warming and the eco-crisis into the promise of sustainable living for all. Your dedication, your priority, your energy, your creativity, and your problem-solving skills are our essential framework to address this challenge together. And succeed we must. And I'm confident with your initiative and through your focused nurturing of our vast, unlimited assets of the creative energy of our young ones, we will reach the promise of sustainable living for all. So a very hearty welcome again, and let us march forward together. Vande Mataram.
Thank you, Dr. Bhattacharya, for those inspiring words. I now call upon Professor Chirosree Roy-Choudhury to give her address. By way of a very short introduction, I should say that she is a professor in the Department of Electronics and Telecommunications at the Indian Institute of Engineering, Science and Technology. I always seem to trip over saying that. And rather than give any kind of extended introduction, I will simply say that her topic is Future Sustainable Life in India, Challenges and Opportunities for the Younger Generation. At the end of the presentation, there will be a very short period of time for a couple of questions. So I would suggest that you put your questions in the chat box. But now I turn the floor over, the virtual floor, to Professor Chirosree Roy-Choudhury. Over to you.
Yeah. Thank you for your kind introduction, and good evening to all the distinguished members of GAABESU and my colleagues and respected teachers present here. I'm very happy, it's my pleasure to speak on a very pertinent topic related to sustainable India. Well, honestly, I have not worked directly in the area of the sustainable development goals, but some of the research in our laboratories do adhere to some of the sustainable guidelines. In this time, in this lecture, I would actually try to highlight the challenges and research opportunities for the younger generation in India to realize a sustainable life in the future. Whenever I think of sustainability and its importance, few thoughts always flash. We cannot really solve our problems with the same thinking we used when we created them. The greatest threat to our planet is the belief that someone else will always save it. Someone else will always do it. Why we have to bother everything? We do not inherit the earth from our ancestors. We rather borrow it from our children. And we never know the worth of water till the well is dirty. So it's so true that when the major discoveries have been made, we never thought of the threat they would pose towards sustainable existence. And hence, to solve the problems, definitely alternative methodologies need to be adopted. So we have to think in a different line. And in this talk, I would just like to highlight some of the brilliant ideas being executed globally and some of them in our country also, where alternative thinking methods are projected. Yes, definitely looking at the devastating effects which the climate change have done in our life and some of the odd diseases that are health issues that are coming up with young children and adolescents, it is no longer an option for us to decide whether we should work for sustainability or not. But in fact, it is our mandate to do something to achieve some of the sustainable development goals. In fact, this is a very young story. This is a very interesting story about a young girl. Many of you might have heard it, Greta Thunberg from Russia, who started a campaign of school strike for climate change. She has been suffering from a very rare disease called selective mutism, where she lacks the communication power in certain cases, and only in very selective cases she tries to open up. So she attributed to, or the doctors have attributed it to, an in very much indirect effect of the climate change. And she's considered as one of the most active climate activists even today. So how do we define sustainability? These are well-known definitions. The development that meets the needs of the present without compromising definitely the ability of the future generations to meet their own needs. So we definitely have to fulfill our needs of the livelihood, keeping in mind all the eco-friendly aspects, and also keeping in mind the economical aspects, because ultimately, whatever we do, business has to thrive, economy has to thrive. So in the pursuit of doing something for achieving the sustainable development goals, we cannot forget the financial aspects also. And definitely the way forward is to work towards reuse, reduce, and recycle, these famous 3 Rs, which have almost become the buzzword at present, and to go green in all aspects. So I'm not going into all the 17 sustainable development goals defined by the UN. All of you are aware, but I'll highlight the challenges and the opportunities in some of the main aspects in our country. So clean air and water, poverty and quality education, which is very, very important for us. And it's a challenge actually to meet the level of the, to reduce the level of the poverty that we have today, and to give a quality education to a greater percentage of masses, good health and well-being, especially to provide affordable healthcare to the rural sector is still a challenge today. Affordable and clean energy, climate action, these 2 topics were already discussed in details today. So I'll try to highlight the important research which is going on in the other aspects. Okay, for clean air and water and for affordable and clean energy, we know that a lot of research and their subsequent implementations have already helped in the detection and removal of the harmful ions in water. On a large scale, they have been deployed in various locations in our country. Different CSIR laboratories, different institutes of our country, various industry partners, they have actually come up with different gadgets as well as technologies which are helpful for implementation, which have been implemented, and they're helpful for detecting harmful ions like arsenic, fluoride, mercury, lead, and so on. But what is more important is, rather than simply managing the electronic waste problem, sustainability also demands preventing it in the first place. So we should gear our activities in such a way that the question of managing the problem reduces, so that the problem which arises reduces, so the management will be easier. For that, harvesting energy from biological sources is one of the very important area which can be explored, and which is being explored currently globally to a large extent, and plenty of research, some research has already initiated in our country for harvesting energy from biological sources. So I'll just highlight some of the important work, the latest important work that has come in these areas. Then efficient and eco-friendly techniques for recycling the electronic waste. We from working in the electronics background, electronic disciplines, we do generate a lot of waste, and most of the time we do not bother also to think about them, but there are various interesting techniques, eco-friendly techniques, in fact, to recycle some of the electronic waste that are generated in mass scale. A very interesting research at the University of Cambridge, which has come up recently in just 2020, they have developed a lithium-ion battery that can be directly charged in sunlight without requiring solar cells. So the workhorse of this new battery is the vanadium pentoxide nanofiber. So material science has got a very important role to play. Material scientists and chemists, they really do have a very important role to play, because materials can really create magic. This interesting material, vanadium pentoxide nanofibers, what they can do is, when light enters through a glass window on the cathode side of this cell, this material stores lithiums and also has the capacity to harvest light to generate electrons and holes. Now, when these nanofibers are mixed with a polymer P3HD, they block the movement of the holes, and the graphene oxide, which is present, also as another material that aids the electron transfer. Though the efficiency of this battery is low for practical use, so researchers are trying to improve the efficacy of this battery by looking for other alternatives. Sustainable Electronics Initiative. Sustainable Electronics Initiative have been taken up by Apple, where Apple has in fact become the first member of Sustainable Semiconductor Technology Research Program, where in the process of the design of the integrated circuit, the models that we use, the type of the floor planning that we do, they should incorporate more of the, more of the greenhouse effects, and the greenhouse gas footprint analysis should be considered while actually doing all the analysis of this integrated circuits, design of the integrated circuits. Because according to a recent survey, 20% of the global energy demand by 2030 will be from the information and computing technology, with chip manufacturing being responsible for this large demand of the energy. So definitely the modeling and the designing should take into account some of the low power criteria, then low space, and various other issues related to the greenhouse gas footprint analysis. Another interesting work, this is basically energy, harvesting energy from the biological source. So it's a sole, a shoe sole, where an interesting material can be coated, which uses the sweat evaporation to generate power. Of course, these are only research efforts, way to go for commercialization, but at least this gives an idea about the alternate thinking, alternate approaches which can be followed and which can ultimately lead to energy generation from alternate sources effectively. So this work has been carried out at NUS, where they have created a prototype of a shoe insole that evaporates the sweat faster than the normal cases, and use the harvested moisture, so that the evaporation of the sweat that has been converted to moisture, and that moisture has been harvested to generate energy. So what has been done? They've used thin film of two hygroscopic chemicals, that's cobalt chloride and ethanolamine. So besides this chemical being extremely moisture absorbent, they can also rapidly release water when exposed to sunlight. And this can be regenerated and reused for more than 100 times. The overall energy which has been harvested at present by this particular technology is sufficient only to power a light emitting diode. But the proof of concept illustrates that this sort of technology can be adopted for batteryless wearables, which can be powered by human sweat, because wearable technology is also very important in defense sectors and in health sectors. So, and in case of wearables, batteryless devices are very important, because we cannot keep on charging the devices that we use for the measurement of our parameters. and keeping, housing the battery in these wearable devices are also a major challenge. So coming up with batteryless wearables using alternative technology is very important. This is another interesting work with fruit peels have been used to recycle the waste from the lithium-ion batteries. So see, this sort of work can be actually done over here also, where orange peels have been used, and the cellulose found in the orange peel has been converted to sugars under high temperature during the extraction process. And it's mentioned that this sugar actually enhances the recovery of the metals from the battery waste. Then a lot of metals from the electronic waste can be actually utilized as metal coating. So it's a process of recycling. And for this also, silicon carbide nanowires, they have been mixed with the printed circuit boards which are not used. And then a temperature processing has been done, and that resulted in a very tough and stable metal, which can be actually used as a coating to the steel, and that prevents the steel from cracking or chipping. So it increases the hardness of the steel by 125%. When the metal which has been regenerated from this e-waste has been coated onto steel, the hardness of the steel further increases. So that's another useful product, a very useful product. This is another interesting work where gold from the printed circuit boards have been recycled, generated by a porous porphyrin polymer. So this particular material is highly selective, absorbing gold. And in fact, cost of the fabrication or development of this particular material is also much low, considered to the number of the amount of the gold that it can absorb, and it can separate from a mixture of different metals. So the selectivity of this particular material is very high, and thus developing such innovative materials is one of the key areas where the research can be focused on. Regarding health and well-being, as far as India is concerned, more than 60% of the population is in the rural sector, and delivering basic healthcare to the rural sector is a challenge and a necessity. For this, what is required is affordable medical devices with extreme point-of-care diagnostic facilities, and coupled with definitely intelligent signal processing unit to give out the readout in the location or to transmit the data to the nearby primary healthcare center is a requirement for the rural sectors. A very interesting work done in West Bengal by a Foundation for Innovations in Health in collaboration with IIT Kharagpur and IIT Guwahati is the development of a floating hospital, which has delivered healthcare, affordable healthcare to the people in Sundarban. And what has been done is some affordable medical devices like point-of-care testing for malaria, point-of-care testing for glucose, and some of the diseases which are pertinent for the rural sector, along with the portable ECG machine and other gadgets which have been made portable and interfaced also with the wireless module, so that the data of the patients, if required, can be sent to the primary healthcare center. So this entire array of gadgets, along with some doctors, they have actually carried the devices to the locality in a boat, and the screening of the patients have been carried out in this boat, and that's why they're calling it a floating hospital. This is one of the very recent report, I mean, that's also in 2019 or 20. Yeah. And then an interesting work on, since in this pandemic, the rapid antigen test for coronavirus detection has become the need of the day. This is once again from our country, from a CSIR lab, where the point-of-care device, paper-based point-of-care device, leading to having all the sample integration, starting from the sample collection point to the result, and carrying on all the RT-PCR equivalent tests in this particular module has been developed. And they have also been tested blindly on various patients, and has proved to be very successful in giving the correct results compared to the standard laboratory-based RT-PCR test. The beauty of this method is all the thermal cycling processes required in the polymerase chain reaction, then the generation of the nucleic acids, the detection of the nucleic acid, everything can be performed in a small gadget like this. And the technology is also based on a very affordable substrate, that's a paper. So this is one of the very important work that has been done in the area of affordable healthcare, and such sort of technologies later on can also be adopted for other diseases which can be carried to the extreme point of care locations in any remote villages. Do I have much time left? Few minutes left?
Go ahead. Go ahead,
Okay.
Chirosree.
Okay, so to cater to the increasing poverty in our country and the low level of education amongst the masses, we can actually apply a lot of our knowledge in electronics, IoT, and AI in various sectors. For instance, in agriculture. So India is an agricultural country, and promoting precision agriculture which can result in improved yields of crops is very important in the rural sectors. Like NIR-based spectrophotometer, handheld NIR-based spectrophotometers, if it can be developed indigenously at a low cost, at an affordable price, then it can be used largely in the various rural sectors, in the various agricultural lands, to monitor the mineral content of the soil, various mineral contents of the soil in field. The present technique, what they does is they extract the soil, bring it to the lab, and do the chemical analysis. And naturally, the results also take certain amount of time to be given to the farmers. So on-spot decision regarding the amount of the nutrients which has to be supplied to the soil is not available with the farmers. So that also results in a delay in the yield. And the labs, also number of labs which can carry out this sort of chemical tests, they are also limited in the rural sectors. So if there's a huge demand, the labs cannot cater to it timely. All the agricultural universities located over there in the nearby locations, they cannot cater to it immediately. So development of such handheld gadgets can actually enhance the idea of precision agriculture in our country. Then for quality education, of course, one positive effect of the pandemic is that no one ever thought before that the use of smartphones can be so rampant for imparting education. So that can be adopted actually to provide quality education to a large section of masses in the rural sectors. And finally, for gender equality, where our country really needs to make a lot of progress even now, is to make awareness about women's education, which needs to be propagated in the society. And for that purpose, and also the young scientists and the faculties, they do have the responsibility of conducting various gender-biased workshops and articulating problems of women, even at the workplace. So myself being a member of IIEST, which is an academy under Indian National Science Academy. So we have actually come out with a recent survey paper where the problems of the women in the workplace have been highlighted in one of the sections over here. So similar sort of surveys can also be carried out by the young scientists. And yes, thank you for taking a bit longer time.
Thank you, Professor Roy Chaudhary, for an excellent presentation, particularly your overview of the use of modern electronics and wireless communications in the delivery of healthcare and education services. It's very rare to have somebody use terms like the Internet of Things and artificial intelligence in these areas. But having worked for the government of Canada for 35 years and having had to deal with some of these areas, it's very, very heartening to see that such technologies are being considered for deployment in improving agriculture and health services. Before turning the thing over to questions, let me mention one other point which came to my mind when I...
Probita, just 1 second. There is a question, okay? So
Yes, okay.
once you finish, yeah.
First, I would then ask Shreyan to go through the questions in the chat box. I believe Mr. Borun Boshak asked a question.
Should I?
Chirosree chat box ta dekho.
Yeah, sure.
How-
Okay.
It's
Yeah.
a question from Borun Kumar Basha. How is IIEST developing quality videos for online teaching and also laboratory or workshop experiments and demonstrations for the students and also for community? Yeah, that's the question.
Yeah.
It's not really.
So yes, regarding the laboratory and the workshop experiments, we conduct the live demonstration. And recently we are carrying out one project where so long the live demonstrations where the technicians in the laboratory, they were conducting the experiments and the students were observing the experiments from their residences online. They did not have the control on the various hardware parameters in the experiments. They were controlled strictly by the technicians. They could view the experiments and get the results also online. So regarding the laboratory and the workshop experiments, this is the state of the art at the present. So we have taken up a project where through the smartphone they are using from their residences, an app will be provided whereby they will be able to control some of the hardware parameters of the experiments also and get a feel of how the system is working instead of just observing. So that project we have taken up at the moment, but it has to be realized. So in small scale, we have realized it with one of the equipment, but it has to be interfaced with the majority of the laboratories. That has not yet been done. Like with few of the basic electronics experiments, we have tried to develop the app which they are using. Some of the students are using at the moment. In fact, it's the PG students and the research scholars with it. They tuning some of the parameters like the voltage, the frequency of the waveforms, and observing the real-time change in the output of the experiments. So they are being able to tune it from their home. That means controlling the actual hardware without coming to the laboratory and observing the real-time output also at the same time. So this is one of the improvements in the online laboratory demonstrations that we have taken up.
Thank you, Professor Roy Chaudhary. In the interest of time, I'm afraid we'll have to move on. If there are more general questions, we may have time to ask them at the end of this webinar. I would like to make just one further comment. I noticed that Professor Roy Chaudhary mentioned the Brundtland Commission. The First Nations of North America, I'm speaking to you from Canada. The First Nations of North America used to have a saying, which can roughly be translated as follows. When you make a decision, think of the impact you will have for the 7 generations to come. With that, I ask Dr. Deepanjana Adak to take over and proceed with the next item, which is the plenary panel discussion.
Thank you, sir. Good evening and good morning, everybody. I'm going to start the next session of this seminar. It is widely assumed that younger generation are more concerned about global issues. These generations who grew up in digital age are thought to be more health conscious and environmentally sensitive. The media usually emphasizes the readiness of these younger generations to speak up for what they care about. So now we will hear from millennials on various aspects of sustainability and possible ways to become self-reliant by maintaining harmony with our mother nature. Now moving on towards our first lecture of this session. First lecture is prepared by Somnath Adak on potable water crisis. He has completed MSc in Geophysics from IIT Kharagpur with specialization in nuclear geophysics. He is presently a visiting scholar at Blue Marble Space Institute of Science. He has deep research interest in planetary geoscience, nuclear geophysics, and hydrology. Over to you, Somnath.
Hello, am I audible?
Yes, you are audible.
Yes, go ahead.
Okay, thank you. Is the presentation is visible to everyone?
Yes, go ahead.
Okay. Hello everyone, I am Somnath and today I will be presenting my views on potable water crisis. At the very outset, I want to thank GAABESU and ADI Associates for giving me this opportunity to present this discussion at a platform like this. As you know, freshwater crisis is a problem of a global concern, and all of us are well aware of it. Today, my aim will be to give you a more clearer picture about it. 71% of Earth's surface is covered with water, but still, why there is water scarcity? Because almost more than 97% of the water is not usable and for any purpose or daily courses and for drinking purposes. Only 2.5% of the water is usable for drinking and other purposes. Of that, 70% of it is inaccessible in the glaciers. 30% of it is in the groundwater, which is which takes energy and cost to extract it. And it is the main concern now, which I will be discussing next in the discussion, that how it is affecting, what is the main problem with groundwater. And rest is the surface and other fresh water, and of these, the lakes, the rivers, and swamp are the things that are called the surface water resources which people can use. Now I will be giving you a short history of water on our planet. The origin of water, it is a debatable topic about the origin, how actually water came in the picture of Earth. There are a line of thoughts, like one of the hypotheses is that the water in Earth is of extraterrestrial origin. That comets and asteroids brought water, and the planet Theia, which is responsible for many believe that it is responsible for the formation of the moon, brought a lot of water to our system. Other hypothesis also there, that water was always present in Earth, and after that the cooling stage, when Earth was in a very hot state, after when in the time of cooling there was degassing, and slowly that atmosphere was created and rainfall started, and slowly water filled all over Earth. And after that, living beings came into the picture, and slowly life evolved on Earth, and human beings came. After human beings came, the civilization started. As you can see, that most of the ancient civilization grew near to the river sources, like like here in China, it was the Yellow River. In the Indus Valley civilization, it was the Indus River. The great city of Babylon was formed near Tigris, and slowly it started. civilizing more and more, developing more. A major change came in the mid of 18th century when industrial revolution started. There was huge demand of water in the industrial scale for goods and energy sectors. Not only this, the technologies developed how to extract lots of groundwater by the pumping, and slowly, there were factory waste which were dumped in directly into the freshwater sources. And slowly, and since then, from the mid 17th century, since the industrial revolution was still recklessly misusing groundwater. And today, what is the situation today? We were aware of the Cape Town situation that occurred in 2019, the day zero, when none of the taps were providing any kind of water. There was no water in Cape Town, and similar kind of day zero are predicted to come in the most of the metropolitan cities. In that, Bangalore is from India, and other countries, other cities, major cities like Beijing, Karachi, Istanbul are going to face a similar kind of day zero in the near future. Now I'll be discussing what is the major problem, that means why this water scarcity is really happening. The first point is that increasing population. As you can see this graph, that there is a huge increase in the population in the last just in last 1 century. We had a huge population increase. As the population increases, the demand of goods increases, and similarly water also increases. There are indirect problems also, that as the population will increase, the percolation rate will also decrease, because most of the places on earth will be covered by concretes and all, and that's also indirect problem that may happen because of the increase in population. Now I want your attention to this image. You can see that 70% of the water is used in the agricultural sector, 22% of it is in the industrial sector, and 8% are used in for just personal use. So bad agricultural practices, mainly that like using wrong crops to grow, using primitive irrigation practices, can hamper a lot to the ground, to the freshwater sources. Other problem is already the water is too less, it's too scarce, as I have already told, and we are polluting it with the factory waste or the medical waste. It is another big concern. At community level, which means for household courses, we need to save water and make other people also aware that there is a huge concern with the water, with the groundwater or any kind of freshwater problem. Now coming another point worth mentioning here is, I feel that water is very undervalued. Why I'm saying like this is that how much we spend on getting a bottle of mineral water now. It costs around 15 to 20 rupees. But just imagine that if this mineral water was used to grow rice, and after that, of the whole all the process, after all these processes, if it came to our plate, then how much should be the cost of a plate of rice, means what we are having on our dinner table. It means it is very clear, not in the case of rice, other products like cotton clothes or any kind of, it is directly or indirectly dependent on water. So if we are paying so much for drinking water of a liter for 15 to 20 rupees, then I feel that really water is very undervalued, and people are reckless in misusing it actually. Now, I want to say that I guess I have made it pretty clear that the water scarcity problem is a global scale, and research and development, many subjects are going to put input to make the situation better. Politicians, engineers, scientists all have their own work and they are doing it. But being a geoscience student, I want to express you all about how geoscientists are contributing towards the water scarcity problem. All the geology of groundwater, subsurface water and surface water, are dealt by geoscientists that are called hydrogeologists. They use it is a multifaceted or multidisciplinary subject where we use different tools of geochemistry, geophysics, remote sensing, geographical information system, predictive modeling and all to understand water, actually fresh water. For that, we use satellite, unmanned aerial vehicles, borehole and ground surveys, and to understand the surface and subsurface observation. We also do chemical analysis on the water to understand the history and quality of water. The tool mentioned above can be means all these tools can substantially help to search where the water resources are, how to extract it properly, check its quality, supply it in a very supply to people, and maintain its integrity and in a very sustainable manner. Now, I want to give you a brief case study kind of thing about two major water related problem in our own state of West Bengal. First is the Bengal arsenic problem, and the second will be the saltwater intrusion or the problem that are facing in the Sundarban. The Bengal arsenic problem the first case of Bengal arsenic problem came in 1982. Since then, 40 years have passed. We are well aware the contamination rate, but little has changed since then. To give you an overview, first of all, arsenic is a carcinogenic element, and it causes various kind of diseases, various kind of cancers, skin lesions, cardiovascular diseases, type 1 diabetes, and other immunological disorders. The arsenic in the Bengal basin is of natural and geologic origin. It is debatable that what means actually what is the reason of actually the formation of arsenic in Bengal basin, but it is believed that that arsenic reservoir is in the Himalayas, in the Sanko-Future zone, in this part. It is in the serpentine rocks which are arsenic rich. Then an obvious question arises: if it is if the source of the arsenic is here, then why it is not getting whole over the India like that? There are other Himalayan rivers also which should be affected by this kind of problem, the arsenic problem. Why only this Bengal basin is getting more affected by it? There is a reason for it also, that in this region the condition is very arid. So the river what originate in this region since this region is so arid, the reaction that which changes serpentine to arsenic rich smectite is not possible here. But in case of Ganga, what happens that rocks are eroded weathered from here and comes to this lower Shivaliks, this region. Here they are immobilized for a time being. After there is a tectonic activities and rainfall, then this arsenic is again mobilized and comes to the Ganga basin in this region. After that, again they are immobilized in the oxidizing condition. But due to anthropogenic activities and this region is now the underground region is getting a reducing condition. The reducing condition due to the due to microbial activities which are directly or indirectly related to anthropogenic activities, that the arsenic is again getting activated, and now it is affecting all over the population in this part of Bangladesh and West Bengal. So what is the remedy to this problem? The only remedy to the problem that we cannot expose more of the population anymore to this arsenic rich water. So what we can do, that we can tell the population to use treated surface water and avoid the groundwater, and create more and more arsenic treatment plants. Now coming to the saltwater intrusion problem in Sundarban. all of us know that Sundarban is the largest delta in the world. It has a huge biodiversity, and the mangrove, the Sundarban mangroves are natural protectors of us. They fix a lot of CO2 gases and save Bengal from huge natural calamities like cyclones most of the time. But the surface water of Sundarban, actually the rivers, are getting salinized due to the seawater increase day by day due to global warming. The uncontrolled abstraction of groundwater in Sundarban has also made the made the aquifers also contaminated, because that uncontrolled abstraction lead to land subsidence, declining base flow of the rivers. They lead to saltwater intrusion into the aquifer and degrade the quality of water slowly. Coastal aquifers of Sundarban are so badly salinized that it is not fit for consumption now. It can be used for household purposes and aquaculture. 70% of the residents of Sundarban do not have access to safe drinking water and primarily depend on deep aquifers. Now I'll be talking about few points about the remedy, that how can we save, means how can we situation better of the water crisis. First of all is the desalination, in which ocean waters are changed to fresh water by using energy. But the main problem with this process is it is a very energy intensive and cost intensive procedure. But scientists are working on it to make it more cheaper so that it can be made for greater use. India also has many plants. One of them is in the south of India. It is integrated with a nuclear power plant. Cheaper purification techniques so that fresh water, or means clear drinking water, is available to remote location. There is a point that I want to discuss here, which may not, many of us may not agree, that as I have already told you about that, I feel that water is undervalued. So increasing the taxes on water may make people realize how much it is important, may change their lifestyle, how to save it, and slowly the system may change. And the tax and revenue that is raised from the imposing of water taxes will be used for the better research in this field also, so that we can have a better we can have a better situation from this problem. Better agricultural practices, and it is the work of the policymakers that better agriculture, mainly the irrigation practices are used that are more modern, which will be using less water. Proper choosing of crops. Some areas where there is already water scarcity, they should not grow the crops that are more which consumes more of water. They should switch to different kind of farming or different kind of crops. These things, and there should be a clear monitor on how industrial waste are disposed on the water into water, how much treatment they are done. It is, means most of the companies are misusing these practices, that they are not properly treating the industrial waste and directly disposing it into the surface water resources. The example that now comes to my mind is the situation of Yamuna. Most of the industries near Delhi have been disposing their waste into Yamuna, and we are very aware what is happening now. Last time I summarize what I have in the of water. Then I told about the reasons of crisis. Hello. Then I went to importance of earth science in this research and discussed about 2 case studies. I talked about few remedies also. And at last, I want to say that I am very hopeful that in the near future, the situation will be better with our sincere efforts and everything. Following up the references of papers that helped me to make these slides. Thank you.
Thank you, Somnath. That was extremely interesting and informative. I'll request listeners to please put their questions in the chat box. We can not take more than 1 or 2 questions. Moving on to our next speaker, Mr. Silajit Manna, who is incidentally my colleague. He has completed his BTech from Kalyani Engineering College in the area of electrical engineering and is presently working as a JRF at IIST Shibpur. We are working in a DST-IIST solar PV hub at IIST Shibpur. I'd like to briefly introduce our hub because it is a renewable energy. It mainly works on the area of renewable energy, and it is directly related to sustainability. The vision of the hub is to introduce, practice, and expand a sensible, comprehensive strategy of photovoltaic technology education and research through different phases to improve lifestyles in environmentally friendly and non-polluting ways. Our vision also recognizes incubating of next generation green technologies through partnership with academic institutions and the industries. Our mission is to develop cutting-edge research as a frontline R&D incubator through a multidisciplinary approach in the field of PV technology. In this pursuit, many young members like Silajit have joined our hub and with their relentless effort giving us sustainable hope in the area of green and sustainable energy. Over to you, Silajit.
Hello, am I audible? Hello,
Yes,
am I audible?
You are audible.
Is my presentation visible?
Yes.
Thank you, Deepanjana. Thank you, everyone. Thank you, GAABESU and Adi Associates for giving me this wonderful platform to talk about such problems. So good afternoon, good morning, everyone. Myself, Silajit Manna from IIST Shibpur. Today, I'll be representing my views on the solution to energy crisis, transition from conventional to alternate, with emphasis on concept, possibilities, and strategies. So energy crisis and the right lens to look at it. The energy crisis is not a very new term, and it has been discussed for long times at different parts of the world through decades. But what should be the right lens to justify it or to look at it? Now, crisis is generally meaning an intense time of intense difficulty or danger where some important decisions must be taken. So it is analogous to a point of a disease when an important change takes place, indicating either recovery or death. So adoption of strategy is very important, the success of which can ensure us a better future and the failure of which can also ensure a much worsened situation than the present one. So mere venturing into renewable sources will not do suffice. There is more to it. Now, this is the present energy scenario in India, as many of you are aware of it. That is from the left chart, we can see the industry and domestic as well as agricultural sector, they constitute of the majority of the energy consumptions in India. Whereas from the right pie chart, we can see that the coal still continues to be the largest, continues to share the largest portion in the installed energy capacity with a energy share of 53.9, that is 54%. But the good thing is, or the ray of hope is that the renewable energy installation has increased up to a substantial amount, that is 35.4% in the last recent futures. Recent past, sorry. Now the interconnection between the sector, if you can look at the red dots, these actually represent the total energy demand in numerical value. So in 2020, it was 880 megaton of energy instead of previous year's 929 megaton of energy. But we have to keep in mind that in spite of this severe COVID pandemic situation, the energy demand has not been reduced that much. Whereas one good thing is, if you look at this yellow bar, this basically represents the energy installations in renewable energy installations in India, which has increased even in this pandemic time. Now, there is another energy demand analysis which is done by the International Energy Agency and was published in the International Energy Outlook 2021, where they have made a statistical approach to predict the energy demand of India up to the year of 2040. And in this process, they have taken the energy demand of 2019 as a standard 100 value. So naturally, there is a dip due to this COVID-19 pandemic. So if you can look into this, if no renewable energy or green policies, whatever are there in the pre-crisis situation, by the time of 2040, the energy demand will be, energy demand index will be 193 or closer to 200 than the present 100. So it is huge, almost twice. including the stated policies, that is policies in use by the government or the private sectors, this will reduce a bit up to 170, still being a more than the 100 value of 2019. But if we can take a sustainable development scenario, then this demand index will further fall to 123, only 23% increase in the energy demand. So curbing the energy need than meeting the energy demand. So this we can start from the very root level, that is the domestic energy control, like solar cooker and biogas plants. They are very well known concepts, but if you can somehow spread the awareness among the masses through government policies or through awareness campaigns, whatever, if you can increase their use, this might be helpful. Now another idea is that green vegetables are less processed foods. There are studies showing that food industry, the energy requirements are very high, and the gas emissions are more than sometimes they become even surpass the automobile gas emissions. So now the green vegetables or meat, this can be a matter of personal choice, I agree. But the less processed foods, that is whatever you eat, be it vegetable, be it meat, whatever, if you can acquire them from local sources instead of some industry, then the local economy will also shoot up, as well as the energy demand and the gas emissions will also be less. Thankfully, till now in India, this food processing industry has not developed that much compared to the West, but still it needs to be taken care of. Solar lighting. Now this has two aspects. That is, one is the normal street lighting to solar panels, which has been explained wonderfully by Professor Vanu Chaudhary sir in the previous day's meeting. And another is using the solar light directly by mirrors to enlighten the rooms, especially in urban areas, both in residential or office sectors, because there are tall buildings. So even in daytime, the congested buildings, so even in daytimes the lights needs to be switched on. So if you can use the sunlight and we can make the buildings in that way, so we can reduce a lot of energy demand. Finally, making a habit of using lesser energy, that is cycling or walking. So what's the point of covering a small distance of 1 kilometer, 2 kilometer in a car or motorcycle? We can easily walk it. So these are some basic steps that we can take at the very grassroots level to reduce the energy demand in India. As in Europe, we out in the West countries, we know that there are several the separate pathways for the cycle or for the persons who use cycles along the normal sidewalks. Now, in the second part of it, that is the meeting the energy demand, that too also in a green way. It has also two main aspects that is coming up right now. One is the proper transition into electric vehicle or solar vehicles and the green energy cultivation. Now, electric vehicles or solar vehicles, they're also pretty well-known concept. I'll not go deeper into the basic concepts. Just to let you know, this on the right image, this is a solar toto that has been developed at IIEST Shibpur at our very own department. Now, green hydrogen. Now, this is basically a less known concept with respect to the EV concept, where in India, we have I see huge chance of it, where we can use our present renewable energy installations like the solar or the wind to produce the power which will be used to dissociate the plenty of water present in India. I'm talking about all kinds of water, not only drinkable, also the other types of water, to produce hydrogen and then to store it either in hydride storages or in fuel cells or in any kind of methods to meet our energy demand. Now, as in case of like electric vehicles or etc., one of the main requirement of the batteries, that is lithium ion or be it the vanadium pentoxide, both of them require rare earth materials, and that is exclusive to some special geographic zone in the world, which is not present in ample amount in India. So for us Indians, hydrogen or green hydrogen cultivation might be a very useful solution for the upcoming future energy crisis. So implication of faulty implementation, the sweet spot to transit to the alternate. As I have discussed or mentioned a lot about the strategies, there are two recent case studies that has to be looked into with much care in recent times. One is the Sri Lankan case study. In Sri Lanka, in past 5 to 10 years, they tried to completely substitute the total farming process with organic farming, but they didn't have the proper infrastructure, and they also didn't have have very poor planning or illogical assessment, I would like to say. So the whole transition failed, resulting in an economic crisis in Sri Lanka. So organic farming is a green future. But even if you don't plan properly, the green future can lead you to disasters. Second point is the Indian coal crisis case study. Just in the first quarter of 2021, there was a possible chances of power outage in every major Indian cities due to lack of coal supplies to the thermal power plant. Now, coal is very conventional in India, right? Organic farming is unconventional, but coal is very much conventional. But still, lack of planning and lack of situational awareness made it into a disaster. That shows that we need two things. One, as per the Sri Lankan case study, a strong base of change. And second, as per the Indian coal case study, a contingency plan. So whenever we have in this country, whenever alternate has been tried to be implemented, be it any kind of alternate, there are basically two sets of problems. One is the technical challenges, one is the administrative challenges. For the technical challenges, such as the low efficiency, say for the solar cells, the irregular source, the massive installation cost, not fully proven technologies, or high risk factors like the nuclear technology. But the one good thing is all of this can be solved. There are some particular pathways to solve it. But on the other side, the administrative challenges like the less awareness in public, lack of industrial policy, loose safety protocol, like I cannot what we have seen in like Chernobyl or Fukushima, we cannot afford to have it in India because many people will die. The lack of policies in context of global supply chain. That is, in India, the companies which want to take up renewable technologies to incorporate in their product, they don't get much support from India to compete with other giants from countries like China. So these factors need to be taken care of very carefully. So combining all the previous slides, we can sum up that the possible strategy meeting the goal of Pancha Amrito as taken up in the COP26 in a green way. That is, policies at both higher and lower levels of the government to avoid collision. Both the common people of the India, the lower stratum of the social pyramid, they have to be make aware of the possibilities and of the good deeds of these renewable sources, as well as the government, the higher authority planning should support them. They should not work in different ways because collision has to be avoided. Second, education, especially technical education, should be built on sustainability concept. Like I have done my BTech in electrical engineering, but I can say that even I have passed out recently, but in my course there were not much about the renewable technologies to produce current or produce electricity like the solar or the wind. So there has to be incorporation of these topics from the very beginning. Third is the localization of energy grid or connecting microgrid. Now, if there are ample amount of local grids or microgrids present just to support the national grid, then at the time of crisis or power outage, they can support us. At the same time, the generation can also, the generation through the microgrids can also reduce the burden on the national grid. Like as Professor Ganachowdhury rightly pointed out, the net metering system that is currently coming up to the much prominence, where people will install solar power plants on their roof, and they will be connected to the meter that is connected the meter or connected to the local supplying authority. So whatever they will produce, except their needs, they will sell it to the company and they will make money out of it. And this will also be in a green way. That is because it is generated by the solar energy, not burning any kind of coal or petroleum. So fourth is subsidies to help companies and small startups with innovative ideas like Prefect Dynamics. Now there is a company based on Bangalore called Prefect Dynamics who has come up with a brilliant idea of not selling but renting, giving electric vehicles for renting with a substantially higher mileage than the present electric vehicles. So if you rent it, you don't have to use much of your money to maintain them. Secondly, because the companies with a lot of money will maintain them. Secondly, if you have a car, if you don't have a car, if you just borrow a car, you will have the habit of walking for the smaller distances. So at a certain amount of time, the local number of vehicles present in the road will be reduced. So the gas emission as well as the energy demand will reduce. And that too, we are using electric vehicles, so the pollution will also reduce. Have a contingency plan. As we have seen in the Sri Lankan case study, they didn't have, or in the Indian, they didn't have a contingency plan. So suppose we are at any power sector or any sector of the society, we are trying to convert ourselves into an alternate plan. But what if we fail? Then we have to have enough supporting systems so that our systems don't get stuck. So the next point might be a bit controversial, but that make policies according to the urgency, not according to the economic profit. Always. I'm not saying each time, but at least sometimes, because we cannot expect the local people to understand, the local people who are not educated to understand the the urgency of the situation. But we can, if the industries who are well aware of the whole situation, if they can help in this cause, then this situation will be eased easily. And lastly, the hybrid renewable energy harvesting. So instead of putting only solar, only wind, etc., put in a microgrid manner or combine them, so your net output will be much higher. So some important steps that has been taken out by the government of India, as discussed again by the Professor Ganesh Chaudhary sir, like the policies such as Kusum or Ajay Atol to introduce renewable energy deeply into the society. Introduction of the power purchase obligation or the PPO, and the revision of the tariff policies so as to lure the industries to invest more into the renewable energy sector. The provision of diverse direct and indirect subsidies and basic custom duty on solar modules, especially those are imported ones. This will also help the companies to compete. And lastly, the big companies like the Reliance Industries or Adani Industries, they are interested in investing in renewable, which makes us hopeful for a green future of India. Now, in this light, in this regard, I'll also want to put some light at our IIST Shibpur facilities. So at our DST IIST Solar PV Hub under the School of Advanced Materials, Green Energy and Sensor Systems, we have taken up some green goals as per our research thrust areas, and these are some our hub members, and which we can see, and industrial members as well. So among our main thrust areas of research, the two which I would like to mention is the development of self-cleaning coatings for PV modules and the development of waterless self-cleaning techniques for PV cells. Because solar energy being a green energy, if you can make the process of harnessing a green energy itself a green one, then that will be beneficial for us. So under this, these are some overview of our project works in which we have produced solar cells of different kinds of different technologies with sufficiently high efficiencies comparable to that of industrial scale, sometimes even higher. And this is the self-cleaning of PV modules in which we have been able to develop a technology to produce highly transparent, anti-reflective, hydrophobic soil anti-soiling coatings, so to prevent the soiling and to clean it. And at the same time, we have also been able to produce electrodynamic screens on which I am particularly working on, to remove the dust or soiling from the solar panels without using any kind of water, just by putting some electricity. So there is a video I like to play you. This is a transparent electrodynamic screens on which we are applying some voltage, and this dust we have spread is collected from our rooftop solar panels only in the IIST Shibpur. So now let's see the magic. So as we can see, all of the dust were cleared within a few seconds without using any water. So this technology is in use. We're on the verge of producing it into a large industrial scale, and then to talk with the industries. We have also a module reliability feature where we can test our solar modules or our coatings or our EDS screens, whatever, under different kind of natural calamity conditions or different kind of natural situations, so as to test the reliability. These are some lab facilities that I have, that we have in our IIST Shibpur. Now these are two companies, two startups that has come out from our department called Resolves Power and Elitech Power. This Resolves Power, the solar toto that I have shown a few slides back, has been developed by this company. And the Elitech Power, they produce electrodes in a green manner, or in a less pollutive manner, and supply them to various industries throughout India. So on a conclusive note, we can say that energy crisis is a multidimensional problem requiring proper planning and implementation at multiple stages from the society to be properly dealt with. The administrative changes can create stages for transformation, but only public awareness can assure its sustainability as long as we are not trying to implement it. However, the sweet spot of transition to alternate is very crucial, the failure of which can lead to environmental as well as economic crisis, just what happened in our neighboring countries. Thank you for patient hearing.
Thank you very much, Silajit. That was a wonderful presentation and for sharing your insightful knowledge with us. Now this is the time to encourage the spirit of next millennial, who is probably the youngest among all the speakers, Mr. Amitabh Sarkar. He is a Dinhata College BSc Chemistry student. He'll be bringing attention to a critical environmental issue, plastic pollution. Now I'm going to ask Amitabh to begin his presentation. Amitabh, are you there? If you have any problem, then I can.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Please share your presentation, or I can do it for you. If you have any.
Yes, I am sharing. Ma'am, is my presentation visible?
No. Yeah, now it is visible. You can enter the slide view mode and then just begin your presentation.
Okay. So I am Amitabh Sarkar.
Amitabh, please.
Am I audible?
Yes, you are audible, but please do the slide view mode because it is slide view mode.
Hello.
Can you hear me?
Yes, ma'am.
Please enter the slide view mode. That is in the bottom right. See? In your taskbar.
Yes, ma'am.
You can just press F5 from your keyboard. It will automatically go to the slide view mode. If you can just do that.
And
What?
enable editing. Enable editing.
And,
অমিতাভ প্রেস F5 টা প্রেস করো তাহলেই হবে F5 তোমার হচ্ছে কিবোর্ডে যাও দেখো F5 আছে F5 প্রেস করো
হ্যাঁ wait.
ঠিক আছে অসুবিধা নেই তোমার না হলে এরকম ভাবে
হয়ে গেছে ওখানে একটু স্লো হচ্ছে এখানে
let him go like this only. It's okay, we can see it.
We can see Deepanjana.
Okay, Amitabh,
Let it go like this.
Let's continue.
I think he has some internet issue. So,
hello.
Yes. If you want, I can share the slide if it is convenient for you.
I am in. Okay, ma'am. You share.
Yeah. So you just stop sharing. I will share the screen. for you. Is it visible?
Yes,
ma'am.
it's fine now.
Yes.
Okay. Amitabh, please start your presentation.
Yes, ma'am. So I am Amitabh Sarkar, the student of Dinhata College. I am the student of 5th semester. Today my topic is about the bioplastic, a replacement of petroleum-based plastic. Next slide, ma'am. So we all heard about the plastic pollution. The plastic pollution is the accumulation of the plastic objects and particles in the earth environment that adversely affects our wildlife habitat and humans. Next slide, madam. Because they could, the wildlife are also affected and the sea animals are also affected because they could not distinguish plastic from food and they painfully starve to death because they take plastics. There are also humans affected by the plastic. They took tiny pieces of plastics by their food and water and they become sick and with cancer and like diseases like lead poisoning and more. According to United Nations, a study according to United Nations, we have created over 8.3 billion metric ton plastics as 2017. 8.3 billion, a huge number, and it is growing day by day rapidly. 8.3 billion can make 8.3 billion metric ton also is equal to 822,000 Eiffel Tower. We can make 822,000 Eiffel Towers by that plastic we made as 2017. How much plastic we use? All of them, only 9% of all plastic are recycled. 12% plastics are being burned and they causes the harmful greenhouse gases like methanol. Methanol is about 84% more toxic than carbon dioxide. And then remain 79% of plastics are thrown in the landfills. And they will still remain there for centuries or for forever. If this continues, one day this world become the plastic world. So that we have to make an idea for an sustainable solution and an alternative of plastic. We have to imagine a plastic like which is not made of non-renewable fossil fuels and have to made with renewable materials like plants, bacteria, or even food waste. Next slide, madam. So we made an alternative. This is called bioplastic. And yes, this is also biodegradable, not biodegradable like fossil-based plastics. These bioplastics can break down by their own or with something to help them, like dissolving in water or exposing it to sunlight. Then they can also be modified. Interesting thing is if we add the vinegar in the bioplastic, which is made of corn starch, its flexibility increases. That's how we can increase the flexibility of a plastic. A bioplastic have the potential to reduce the emission of carbon dioxide at least 30%. This is not a big number, but one day it percentage will help us. Just like many types of plastics, there are many types of biodegradable plastics. And next slide. Here I mentioned some. Here I shown some types of bioplastics from which the bioplastics, some materials from which the bioplastics can be made, like biomass products from microbial fermentation and from biotechnology. Here I mentioned the plastic from polysaccharide starch-based plastic. Today I am mainly talking about the cellulose-based plastics. Next page, madam. So why cellulose is used for the making of bioplastics? Mainly cellulose is used for its strength and biodegradability. The cellulose can be found in plant material and the waste from the agricultural crops. And it is also can be harvested from the renewable sources. This cellulose is easily broken down into building blocks, also known as fibrillated cellulose. So we choose cellulose as one of the material to make the bioplastics. But we have some issues with some issues with bioplastics. Next slide, madam. Here I mentioned the cellulose, the structure of cellulose. Next slide. The main problem of the bioplastics is disposal problem. It may take years or decades to decompose a bioplastic, because a bioplastic made of sustainable materials can also be non-biodegradable. Like an example, a bioplastic can be broken into a polythene and water. That's why a bioplastic made from sustainable material can also be non-biodegradable. So we need more infrastructure and policies to deal with its production, consumption, and disposal. Also, we need more land for its resources to make the bioplastics, because this needs more resources, plant resources. So we need more lands. Next slide, madam. So finally, I am discussing is sustainability. Is it a proper replacement of a petrol-based plastic? Can we consider it as a replacement of petrol-based plastic? It does not make sense to alternate all the plastic-based things into bioplastics, because it is not possible, it is not realistic. Because we need, as I mentioned previously, we need more infrastructure, more policies for its production, and also we need some new habits, some challenges like political challenges and infrastructure-based challenges, and it needs huge infrastructure for its disposal. And it is not possible like we throw the bioplastic in landfills and it will decompose easily or its own. It is not possible. But we have some uses of bioplastics, like to food packaging and cutlery sets. Making of cutlery, we can use bioplastics. It can be easily replaceable from petrol-based plastics. But we have to make a habit to reduce our uses of plastics. It is only way to fight with the plastic pollution. Next page. As I mentioned, but replacing all the petrol-based plastic with bioplastic is not just realistic. Bioplastics can be better conventional plastics, but it costs. It is not perfect solution. The only way to curb plastic pollution is to use less of it, whether bio-based or not. So we have to less use the petrol-based plastics. Thank you. It's my ending.
Thank you for sharing this presentation with us, Amitav. Now, while moving towards end of this session, this is the time to hear our last speaker, Ms. Shumona Roy. She has completed MSc in Geology from IIT Roorkee with specialization in geochemistry. She is presently working as a visiting scholar at BMSIS. Shumona, please begin your presentation on sustainable urbanism.
Hello, am I visible?
Yes, you're visible.
Okay. Hello, everyone. I'm Shumona. I'm a student of Applied Geology. And today I will be talking about sustainable urbanism. First of all, I want to thank GAABESU and Adi Associate for this opportunity. So these are the contents. So first I will be introducing the topic. Then I will be talking about geology and its relation with urbanism. Then I will be doing a case study on comparing some ancient cities like Rome and Naples, and then conclusion in the reference. So it is speculated that by 2050, 66% of the world's population, that is 7.6 billion, will be living in cities according to World Population Prospects. Now, these cities will consume 75% of the world's resources. The sustainable development of our cities is of paramount importance because we need to cope with climate change, population growth, congestion, and resource demands. Now, one of the solutions as the study and act of building cities that promote long-term viability by reducing consumption, waste, and harmful impacts on people and places, and enhances the people's physical, ecological, economic, social health and equity. So here we can see that here are the elements of sustainable urbanism, and these are the three main key elements where we have a sustainable natural and built environment where nature and human beings can exist together. We have this sustainable economic development where the economy should be sustainable, resilient, and like people should be they can be happy and they should be paid like whatever they deserve, they should be paid that. And equitable social environment where the society should be fair and impartial, and everyone, every person, every community should be included within this. Now, here I want to highlight what is a smart city or a eco city or a sustainable city, which has information and communication technology and Internet of Things. That means a lot of devices are connected through internet, and information can be easily transferred from one device to another device. And these are the like it provides the following things like adequate water supply and electric supply, sanitation including solid waste management, efficient urban mobility and public transport, affordable housing, good governance, sustainable environment, safe and security of citizens, health and education. So among all these points, I want to highlight that this adequate water supply and electricity supply, we know this water is very important, and it has a lot of geological perspective. Geohydrology of a region is very important, and it also governs what kind of water resources are present, rivers, freshwater resources, etc. Now, in the next slide, we will see that this smart cities aims to improve the quality of urban services or reduces costs. It also specifies our smart management, smart lifestyle, mobility housings, as well as smart economy. So the recurrent theme is how to live better together while respecting our environment. And here is a smart city privileges the waste hierarchy. We have like when we were young, we have learned about this reduce, reuse, and recycle. Hello.
Yes, you are audible. Please
Yeah.
continue.
Okay. So here we have learned about the reduce, reuse, and recycle. So a recurrent theme in today's generation, a lot of people will hear about reducing the carbon footprint. In the West, a lot of people are turning into, they are becoming vegetarians, or rather they are becoming vegans, and they are reducing their carbon footprint because the meat processing industry, it releases lot of carbon dioxide and all. So these are some of the ways we can reduce, reuse, and recycle. Now, uh, a smart city knows the geology of its area and uses technology in harmony with nature for a smart development of its infrastructure. So some of the examples of smart cities are Singapore, Barcelona, San Francisco, London, Oslo. And in India also we have Bhubaneswar, Pune, Jaipur, Visakhapatnam, Bangalore. Even my colleague Somnath has also highlighted that Bangalore has a lot of problems, water scarcity, and Bangalore is a smart city. So Bangalore have to really work towards it. And these are, it has been taken by the initiative Ministry of Urban Development, Government of India. So now I want to highlight the importance of geology in urbanism. So geology is an important tool for surveying a particular area in an urban city, determining the subsurface characteristics. So we have different geological tools for the subsurface and the surface and the subsurface navigations. The GIS and the softwares are there. We can tell a lot of things from that. It also determines how a city grows, whether it will decline or become successful in the long run. We will be seeing an example in our next slides. Geology helps in preventing and or mitigate the possible natural hazards, avoiding their development in disasters. Use of technology in response to a natural hazard induce risk instead of generating security can lead to higher risk and danger. So this is an example that a case study that I want to put forward. It's the case study of Rome and Naples. And in the Republican times, Rome and Naples both were important cities, but Rome was considered much more important than Naples. And there were a lot of factors, and geology was one of them. So, here is Rome, here is Rome, and here is Naples. So both we can see that, and this is the Tyrrhenian Sea. So we can see that both Rome and Naples, they are present close to this Tyrrhenian Sea. And here, from here, we can see that Rome has a river, which is known as the Tiber River. So, okay, the first I want to like to highlight. So this is basically a geological map of South Central Italy, where these are basically they are talking about the different rock types which are present in the area. For example, here we have the carbonate rock types. Here we have some magmatic units, different types of rocks. These rock types are also very important, and the geology, geomorphology are very important. So here we can see that in Rome, it has a river called the Tiber River. And we have all, and we know, like when we have studied in history, like the ancient civilizations, the Indus Valley civilization, the Egyptian civilization, important civilizations and important cities have grown. They had they were able to flourish because they were present close to the rivers, because rivers, they provided water for irrigation, for drinking purposes, for trade, etc. So river is a very important feature here. So the geohydrology of this area is very important. Whereas in Naples, we can see that there is no such river present. whatever water is available, it is from this Tyrrhenian Sea. So, so in the next slide, I will tell you. And we can also see that the Vesuvius, like we have heard about the Vesuvius mountain, the Mount Etna Vesuvius, which are active volcanoes. That means in the past 10,000 years, from these volcanoes, they are very active and they erupt. So this is a very this area is very unstable. So here is a picture where we can basically this is the subduction of African plate between beneath the Eurasian plate. So basically our Earth, we know, is divided into 7 major plates. So we have the crust and the mantle, and the crust and the mantle together make the lithosphere, and the whole lithosphere is subdivided into these plates, which rigid structures. So we have the Indian plate, the Arabian plate. Now here we can see the African plate and the Eurasian plate. So this is a geological phenomenon which is occurring where this Eurasian plate is less dense compared to the African plate. So the African plate is subducting beneath the Eurasian plate. And when subduction is taking place, so this plate is very dense. It has lot of minerals that contains water. So when it is condensed, these water basically it evaporates, and these water as a result, there is a phenomenon called partial melting. It will melt the rocks, and magma is generated, then lava is generated. Then in this region, we will this region, we have this Vesuvius and Etna, this mountains. So this is a very active region. So this region I'm talking about, this Naples. So Naples is very active, and we have to remember that when these volcanoes are generated, they will also cause a lot of earthquakes, shallow earthquakes they will cause. So this is an important discussion. So then I will highlight that why Rome was more favorable compared to Naples. So Rome had developed on small hilltops and had better defense and trade facilities. It was agriculture-based economy, because I already said that it had a lot of freshwater resources. It had a river, so the agriculture was really flourished. Now, the Tiber and Annan rivers, along with many natural springs, were important sources, and trade and communication between the river banks were made by these rivers, and thus it helped the Rome to expand laterally. I'll tell here in this diagram. So this is basically a diagram of Rome from archaic to imperial times. So we can see this is the main city. This is the main city, and this is the Servian wall. It was built during the fourth century BC, and here is the river. We can see the Tiber River, and over a period of time from 4th century BC to 3rd century AD, Rome was able to expand its walls. Here we have the aeroleonic walls, because the area was not that rugged. The expansion was lateral expansion. So now here we see Naples. So Naples, we already have seen that it lacked rivers, large freshwater resources, and natural springs, and the economy was mainly dominated by sea. And we have already shown that this Vesuvius and Florian field volcanoes, which were very much active and they are still are, defended the cities from invaders. But the rugged geomorphology, because when the geomorphology is very rugged, it's very problem irrigation. There will be problem in irrigation, cultivation of crops. A lot of problems would be there. Physically blocked any inland city expansion and made communication and trade arduous, forcing it to grow vertically. Basically, Naples was not able to expand its territory, and it was like the expansion was vertical, and as a result, the more vertical the more it grew vertically, there will be pressure upon the land, which caused landslides and earthquakes. human-induced landslides and earthquakes caused here. So this is the map of Naples, where we can see, basically this topic is a culmination of geology and archaeology, where we can also see that in Naples, compared to Rome, their expansion was not that much. So this was during the 5th century AD till 1734, the whole thing. Not much has expanded, we can see. Now, there are also some problems when we are building a smart city. We have to keep in mind also some problems like hazards related to pollution of groundwater under cities. For example, here's an example where Naples lacked large water resources. Because Naples lacked large water resources, so it dependent on shallow aquifers. So basically aquifers are basically pockets of groundwater, dispersed pockets of groundwater, basically, an integrate web of underground passages and cisterns. So cisterns were also places where they used to store rainwater, basically. So these cisterns, it supplied the city with drinking water, but they had a very poor planning. So there was no clear separation between these cisterns and sewers. So all the waste water and the drinking water, they basically they mixed together, and and then they were exposed to a lot of diseases like cholera. Now another example is that Venice, and we know that Venice, a city of small islands in the center of a lagoon, it had developed upon piles driven into the mud of a lagoon by diverting 3 rivers. So basically, what happened that in Venice, flooding had caused because due to man-made reasons, there were some rivers, and the distributaries of these rivers, they were diverted due to man-made reasons, and it had caused flooding of Venice. So fast urban expansion, rapid population growth, and the overuse of resources may lead to increased disasters. And before conclusion, I would also like to highlight that when we were little, I remember I used to hate history, but now when I look back at history, I want to share that history can teach us a lot of things. For example, from the Indus Valley civilization, I remember we used to learn about their granaries, their drainage system, about the Great Bath, the town planning, the beautiful way they used to do this. So now when I look back, I can say that those knowledge we can easily apply today, because those cities are considered in today's time, they are considered as smart cities. So we can apply those knowledge. So sustainable urbanism is a recent term prevalent in urban design and planning. So, and the recurrent theme is how to live better together while respecting our environment. And sustainable urbanism is important to build smart cities, because the smart city will organize itself to reduce the energy demand and work on efficient and green energy supply. And the main thing is that we have to reduce, reuse, and recycle in a way of reducing negative human impact. The fortune of a place depends on natural and man-induced resources, and to cohabit with hazards, we need to find a balance between human affairs and earth processes, starting from the knowledge of how the earth works. So this is the references to my talk, and thank you.
Thank you, Shumana. Shumana has explained very beautifully how understanding ancient cities may help us plan a better future. Now I would like to begin my conclusion and section that deals with what Shumana has explained and Silajit. In the present time, smart cities have emerged as a possible solution to sustainability problems deriving from rapid urbanization. They are considered imperative for a sustainable future. By 2050, it is estimated that 66% of world's population would live in cities. In this context, renewable energy may be seen as having the potential to truly empower smart cities. Economic growth, sustainability, and quality of life are the goals of a people-centered smart cities, whereas the utilities' goal are to deliver safe, economical, and ecologically responsible electricity. Solar and wind power are critical to attaining both these objectives. These renewable energy sources are presently the most likely to meet utilities' growing demand for reliable, economical, and environmentally friendly energy supplies. Also, the guiding principle of modern buildings in these smart cities has been sustainability, which has raised environmental consciousness in an endeavor to preserve the natural environment of the current ecosystem. One of the important criteria to achieve sustainability is daylighting, which Silajit has mentioned, which affects the energy consumption and indoor environment quality of the building. Glass is an important architectural material and ubiquitously exists in modern buildings, particularly in windows. The modern green buildings allows a much more holistic view of design with an intent to reduce the energy consumption by integrating the glasses used in the buildings with self-cleaning, low emissivity, and thermochromic coatings without compromising the aesthetic and comfort level. Green buildings will not only help in efficiently managing the existing resources owing to emerging energy efficient functional coating, but can also be used to generate electricity by using a rapidly growing building integrated photovoltaics, which is also known as BIPV, which allows us to generate power. With the advancement of PV technologies, new materials are now being explored for BIPV systems for their long-term durability and sustainable power generation efficiency. It should be noted that so far, major progress has been made in BIPV using silicon-based PV solar cells. However, the recent advancement in the field of various organic, inorganic hybrid solar cells, particularly the perovskite solar cell technology, may come out as a promising candidate for BIPV application due to their high efficiency, recently improved stability, and good visible transparency. Lastly, for sustainability, it is important that our renewable energy systems, particularly solar energy driven system, must maintain the power output for a longer time without suffering significant energy losses. Now, according to a report by an International Energy Agency Photovoltaic Power Systems Program in 2019, nearly 114.9 gigawatt of PV system has been commissioned worldwide. With ever increasing PV market share and extremely competitive electricity prices worldwide, the price of PV has reached around $20 per megawatt hour, which is expected to further decrease in coming years. The concentrating solar power generation is expected to reach 183 terawatt hour by 2030. So efforts are being made to minimize the losses and optimize the generation of the output power. Of both PV and concentrated solar power systems is constantly affected by various external factors, one of the most prominent being soil. Dust accumulation could reduce the power output of solar power plant by up to 28% in a period of just 7 days. Annual global soiling loss is estimated to vary from 4 to 40% depending upon the plant location, resulting in a current global annual revenue loss of 3 to 6 billion USD. The dust-covered panels require frequent cleaning with water, either manually or via anti-soiling coatings or by using robots with vacuum cleaners to maintain their efficiency. To date, there is no well-established method for cleaning the solar collectors except water-based process that doesn't provide a long-term sustainable solution against soiling losses. Again, there is not enough water available in the semi-arid desert areas to meet projected needs. Seawater desalination doesn't provide a long-term solution since the salt content in the water corrodes PV modules and impacts marine habitats. Thus, by adopting suitable soiling mitigation strategy, it is possible to minimize the losses and reduce the levelized cost of electricity. A research group in Fraunhofer Center for Silicon Photovoltaics, Germany, developed a model to determine the maximum cost of soiling mitigation for a typical utility-scale PV system. Based on the recent study, it has been suggested that optimized module designing, anti-soiling or self-cleaning coating, cost-effective automated cleaning system and tracker solution may reach a viable cost range at utility scale. Now, Silajit has highlighted on electrodynamic screens, which offers a strong potential for its application in self-cleaning of PV modules and concentrating mirrors by using electrostatic forces instead of water. supporting sustainable growth of solar industries in semi-arid and desert lands without negative impacts on scarce water resources. Research studies at IIEST Shibpur has demonstrated 9% dust removal within 30-second span through EDS without water. It is of critical importance to mitigate the soiling losses by using a sustainable cleaning strategy. In addition to this, we have gained quite promising result in the area of low-cost soiling and anti-reflecting coating prepared by solution-based chemistry and spray-based technique capable of coating large areas. We have been listening to young speakers deliberating in the area of sustainability, and all these valuable insights gives us a new perspective that one should adopt while discussing this issue. Now I'll ask Dr. Rumana Parveen to present her views on potable water crisis and bioplastics.
Thank you, Deepanjana. This is a wonderful session and very much informative session as well as, and good to see that our young minds are putting so much effort to build such a pollution-free world. And in a brief, that Somnath, what has done, that he has mainly focused on one of the burning issues, that is the water scarcity. And most of the cases, he has enlightened the arsenic water pollution and the water intrusion in Sundarban belt in West Bengal. The solution he has proposed are very much promising, and at least they give us some hope that we can at least fight against the all kinds of this global warming, global shortage of potable water or the drinking water. We are concerned about the waste materials from various farms, various municipalities and factories, as these materials have significant effect on the fresh water and thus follows some adverse effects in our human bodies. Our health is very much affected by this kind of water pollution, and most of the cases in every year that this kind of water pollution, they kill more people, even more than all the types of aggression combined. And in this context, it should be mentioned that we have only 2% of fresh water to access. And if we don't take any serious action today, within 2050, it will be a disaster. And apart from this kind of global water pollution, there is another big problem, that is the marine pollution, and which mainly causes the major ecological damages and put the lives of all the marine species in jeopardy. In this context, it should be mentioned that the most of the ocean pollution is mainly caused by the coastal land pollution. And what happens that the waste materials, the metals, heavy metals comes from various kinds of industries, farms. They carried out by the rivers to the coastal water and followed by the ocean. And another problem that may causes this kind of ocean pollution, that is the oil spills and leakage. And they soaking up constantly the carbon pollution from air, thereby they pollute the ocean. Now, lastly, that what Amitabh has raised a very interesting thing. We all are aware about the plastic debris pollution, and he has given an idea of alternate of this plastic, that is the biodegradable bioplastic formation. And he has introduced one of the promising agents, that is the cellulose-based plastic material, which can be used as a biodegradable bioplastic. And this material should be promising material, as these materials can be available from plants, various kinds of bacteria, cell wall, etc. And this has also a multifunctional structure. So these kind of materials will be beneficial for further long-term biodegradable polymers and bioplastics. And that I have already observed that Silajit has given an excellent talk on self-coating materials. Deepanjana has well explained it, and Rumana has also given an enthusiastic as well as very informative idea about smart smart city. So I am very much optimistic that all 4 guys, they have given effective and very much basic ideas to make a better world, a sustainable world. And that's all. Over to you, Deepanjana, to further proceed this session. Thank you.
Thank you, Rumana. Now we will hear a beautiful poem from a young poetess named Iona Mandal. The Amazon is burning. I would like to request Dr. Arup Bhattacharya to say a few words and introduce this young poetess to us.
Thank you, Deepanjana, for conducting this wonderful webinar today. Before I introduce Iona, I would like to express a word of thanks to all of you, to Professor Chirosree, to you, Deepanjana, who marvelously organized this entire thing, as well as the tremendous learning we all did today from the presentations of Somnath, Silajit, Amitav, Samana, and the very thoughtful discussions from Rumana as well. I think we all learned a lot, and this was an excellent set of presentations. I feel very proud of it. Now, going back to introduce you to the young poetess who had been already introduced by Prabir yesterday, but let me add that it's my privilege to know the young poetess quite well. She was born in India and raised in UK by superb parentage and tutelage of Dr. and Mrs. Ilika Chakraborty and Mr. Partho Mandal. Iona has deeply impressed many literary societies of UK and elsewhere through her powerful presentations and expressions. She has received many accolades at her tender age, and we feel very proud of that. She has also been recognized by no other than Her Majesty Queen Elizabeth II of UK. So, in brief, we look forward for many of her creative work in coming days. With that, let's go into her very fitting writing, The Amazon is Burning.
Hello, my name is Iona Mandal, and today I'll be reading a poem of mine called The Amazon is Burning. This poem was written in the aftermath of the Amazon fires in 2019. It seems we have shoved a cigarette into the raw lungs of a baby, choking and spluttering like a broken engine. Even its tears reek of acid. They are black and misted, like the smudged plastic of a businessman's eyes. Laughing with a match lit between their fingers. Irises, fake as a doll's, glow white hot. Does it make you proud, the stinking flesh, the crackling and cries, the bonfire night skies? Burn not the effigy of a long forgotten traitor, but the traitor to earth. Never fight fire with fire. Mother Nature cackles now. a drop of rain spat, drying the last black tear.
Was wonderful and very appropriate.
Moving towards the end of this remarkable and knowledgeable event, I would like to request Dr. Arup Bhattacharya and Mrs. Anjana Ganguly Roy, President GAABESU, to embrace the event with their closing remarks. And on behalf of GAABESU, I promise you that this may be the end of today's session, but undoubtedly, this is a new beginning. Thank you very much.
Thank you, Deepanjana. I will just add one or two sentences. I've been overwhelmed by the quality of presentations in the last 2 days and the tremendous amount of learning that we all derived. And I feel extremely hopeful and powerful. I am very happy to continue our tradition for the last few years to recognize all these young pioneers, and I would request all of you who participated in today's session to please send your email and phone numbers, and may I ask them to send it at least to Deepanjana and if possible to me directly. If not, I will get the information from Deepanjana. We, in keeping our old tradition, we would like to express our sincere appreciation on behalf of the ADI Foundation to acknowledge your participation and wonderful creations. This may take a bit of a time because of this pandemic time, but we'll make sure it happens. So please, all of you, send your email address and phone numbers to Deepanjana particularly. I'll collect it from her, or if possible to me directly. Thank you. And again, my heartfelt thanks to all of you, every one of you for the last 2 years, the participants, the audience, and the wonderful organizers.
Thank you, Arupda. Thank you, everybody. We are really delighted listening the extreme matured presentations by our yesterday's speakers and our young sustainability activists today. Very interesting remarks, discussions. I was following from the audience. You know, someone was questioning, someone was giving the answer. Some of them were our speakers also. And very informative and matured comments from the moderators, both Deepanjana and Rumana. We actually didn't realize how this last 2 hours have passed today. So thanks to everyone. Thanks to ADI Associates and GAABESU, whoever has made this possible. Thank you, good night and good day. I would like to declare the webinar, 2 days webinar, closing today. Thank you. Tultul can stop recording.